So in the next part of lesson 2, we're looking at dividing exponents. In general, if x is a non-zero value, in other words, the base cannot be 0 for this rule to apply, and m and n are positive integers, so we're looking at the exponents being positive. If the exponents are negative, there's different rules that will apply, and we'll look at those later. And so if we're looking at x to the m right here, divided by, because our fraction bar means divided by, then we're looking at subtracting the exponents. So when we're multiplying the same base, we add the exponents. When we're dividing the same base, we subtract the exponents. And so that is m minus n. And that, of course, is that m is greater than n. So we're looking at exercise 15, 7 to the 9th divided by 7 to the 6th is 7 to the 9 minus 6, which is then, of course, 7 to the 3rd. Now, the reason this works out is because we can write out the factor. So, and the reason this works is we could write out the factors. So we see 7 to the 9th over 7 to the 6th, and what we could do is cancel all the fractions that would equal 1, and you can see that we end up with 7 to the 3rd. So we're just doing that canceling out, but in a shorter form using the subtraction. And so this would be 8/5 to the 9 minus 2, or 8/5 to the 7th. And then looking at exercise 17, again, just highlighting that the negative base should be in parentheses. So we have -5 to the 16 minus 7, and so that should be -5 to the 9th power. And for exercise 18, we have 13 to the 5th divided by 13 to the 4th, and so that should give us 13 to the 1st power, which of course we could just write as 13. So if we're looking at exercise 19, a and b are non-zero numbers, then the answer, the following number, is going to be ab to the 9th over ab squared. So we're just subtracting the exponents. And so we're going to take those and say, okay, then that is a over b, that value, to the 9 minus 2, which of course is just that a over b to the 7th. And then for exercise 20, just looking at that again algebraically, x is a non-zero number, so that is x to the 1st, because it's 5 minus 4, which of course we can just write, when it's to the 1st power, we can just write the number as is. So for the next exercises, we're seeing if we can write them simplified. And it's important to remember that if they don't have the same base, then you cannot subtract the exponents. So when we're looking at this one in the beginning, the 2 and the 4 are not the same base. Now we can think about that 4. So there's our little thought bubble. And that 4 squared is 4 times 4, which is 16. And 16 as a power of 2. As we can think of that as 2 times 2 is 4, times 2 is 8, times 2 is 16, so that is 2 to the 4th. So that's really the same thing as 2 to the 4th, and so we can think of that as 2 to the 7th over 2 divided by 2 to the 4th is 2 to the 7 minus 4, which is 2 to the 3rd. So we can only simplify it if we can kind of break it down using the same base. For exercise number 22, we're looking at those with the same base, so this would be 3 to the 5 minus 2 times 2 to the 8 minus 3. So thinking through, when it has the same base, we can subtract those powers if we're dividing. And so we get 3 to the 3rd times 2 to the 5th. And then we could simplify that more if we were going to multiply it out. We're just going to leave it written as exponents right now. For exercise 23, we have 3 to the 23rd over 27, which again, not the same base, but we want to think about how we can write 27 differently. So if we think it through, then 27 is the same as 3 to the 3rd, so we can write that as 3 to the 3rd. And then, of course, that gives us 3 to the 23rd divided by 3 to the 3rd is 3 to the 23rd minus 3, which then would be 3, oops, there we go, 3 to the 20th. Let's see if I can write that a little bit better. 3 to the 20th. And then looking at exercise 24, we're looking at subtracting only those with the same base. And so we have then negative 2 to the 7 minus 5, and so that is negative 2 to the second power, times 95, and we look at those powers. 5 minus 4 would be the first power, which of course if we're writing it to the first power, we don't have to put that 1, and we can just write the number as is. All right, so looking at exercise 25 is just kind of putting things all together, and a reminder that when we have a value that's just a whole number, it's not written as a fraction, then that has a denominator of 1. So we can rewrite this as 5 over x to the third, and then times 3x to the 8th would be in the numerator, and times a 1, which doesn't really change anything, would be in the denominator. And so we can multiply our coefficients here. The 5 times 3 would give us 15. And then we have dividing of the same base. And when we're dividing the same base, we've just recently looked at that as subtraction. And so we have x to the 8 minus 3. And so that can be written as 15x to the 5th as our answer there. And looking at letter B, again, just kind of rewriting, we've got 5 times our negative 4 times x to the 6th all over x to the third, and we could say times 1 there. I want you to notice that it's just the x being taken to the 6th power, not the negative 4. And so when we're multiplying that, it's 5 times negative 4, which would give us negative 20. And we're dividing with the same base there, and so we have x to the 6th divided by x to the third, so that is x to the 6th minus 3, which is x to the third. And then for the next one, we have 5 times 11 times x to the 4th over x to the third. And so again, multiplying the coefficients, that gives us 55. And we're looking at dividing with the same base, and so we're subtracting there, and that just gives us x to the first, or just x. So we get 55x.